So this is a array. Array A element. First index of element is 1 or -1 if not found. This will be our output. Algorithm will be linear search. For I is equal to 1 to last index of array, we will search our element from 1 to last index of the array. That is, suppose if you are having 10 elements in an array, the last index would be 10. So if ai equals element, return I. If we find our element at ai location, then it is going to return the value of I, that is index. It will return the location at which that particular value is found. Otherwise, it will return -1, that is element not found. So it is there. So this is the algo for it. So what could be the best case, average case, or worst case? Suppose we are looking for the element true, and best case will be the minimum number of comparisons which are required. So best case will be, because we have found 2 at very first location in an array, so it would be the best case, because we made minimum comparison, that is only one comparison we have made. And for the elements 9, 3 and 1, we have to make comparisons 2, 3 and 4 respectively. So it would be average case, means anywhere after the first position, when you will find any element, it would be the average case complexity. And if the element is not found in the list or an array, or it is at the last position of an array, it would be your worst case complexity. That means maximum number of comparisons are required. Fine. So this is linear search. Now sorting algorithm, we were left with bubble sort. So this you have done already in FCKT, but I am going to repeat it again. So this is bubble sorting. Sort the following array in ascending order: 45, 34, 56, 22, 12. In every pass, in pass 1 we have this. First of all, we will take first two elements, we will compare it. If second element is smaller than first, we are going to swap it. So it is written, this is if aj is greater than aj plus 1. This is your aj. Aj index starts from location 1 and aj plus 1 is index number 2. Fine. So we have to compare 45 with 34 and we are going to swap aj and aj plus 1. Now see how this is done. Swap. So now this is 34 and 45. Now you will compare 45 with 56 and already they are sorted, so we are not going to swap it. Then again 56 with 23, 56 is greater than 23, so we will be swapping 23 and 56. Next, 56 is again greater than 12, so we will be swapping 12 with the 56. So it is done. Okay, so this is a first pass. Now in second pass, see 35 and 40, 34 and 45 already, 34 is less than 45, so there is no need for swapping. Then next is 45 is greater than 23. Now 45 is greater than 23, so they need to be swapped. So we will be swapping. See how this is performed. 23 will be swapped with 45. Now 34, 23, 45 and 12. So 45 is greater than 12. So 12 is again swapped with 45. So next 12 is less than 56. So there is no need to swap. So this completes, 12 is 45 and 45 is less than 56. So there is no need for swapping. So again, we have to check for pass 3. In pass 3, 34 is greater than 23, we will swap it. Now 33 is greater than 34 is greater than 12, so we will again swap it. So 34 is less than 45, okay. 45 is less than 56, so they will be swapped. Now for in pass 4, 12 and 23, 23 is greater than 12, so 12 and 23 will be swapped. Fine. So this will be your output. So this is bubble sorting. It is a simple sorting algorithm which compares each pair of adjacent items and swapping them if they are in wrong order. साथ साथ जो element होते हैं उनको बोलते हैं adjacent element, and we will be swapping if they are in wrong order. Means उसको हमने if they are not in ascending order, or we have to sort it in ascending order. Wrong order means they are not in ascending order, or in descending order means whatsoever you are finding. The pass through this list is repeated until no swaps are needed, so which indicates that the list is sorted. So we will repeat the passes till we need no swaps. Means our condition is satisfying that AJ is less than AJ plus 1. Then we will not need any swaps. That means your list is sorted. So as it only uses comparisons to operate on element, it is a comparison sort. So radix and counting sort are not your comparison sort. Bubble sort is your comparison sort. Although the algorithm is simple, but it is too slow for the practical use. So we avoid it in the practical side. So this is how it works. For I is equal to 1 to n, for j is equal to 1 to n minus I, we will keep on checking aj is greater than aj plus 1, then we will swap it. This logically you know how to swap the numbers. So 1 to n is theta of n, average case complexity, we will have theta of n. Then for j is equal to 1 to n minus I, we again need to do n comparison. So it is again theta of n. So it is theta of n square. See, theta of n square. It is theta of n square. So we will write it is theta of n square. Wherever two loops are there, we always use theta of n square because n comparisons for the outer loop and n comparisons for the inner loop. See, we have started from pass 1. This is for pass and this is for the comparison inside the array. For j is equal to 1 to n minus I, because after every pass you will find the sorted element at the last location. And first of all we sort out, suppose we are sorting list of 5 elements. Then in the fifth position we will have the sorted element, then in the fourth position we will have the sorted element, then third, then second, then first, and so on. Fine. So for first I is for the outside passes through and j is for the elements which are inside the loop. Fine. So this is going to be theta and square. Kindly unmute yourself and you can ask if you have any problem or you can raise your hands. Or is it clear? Please let me know. Parth, are you there? Parth, are you there? Nazpreet?
Yes, ma'am, it is clear.
It is clear.
Yes, ma'am.
Nazpreet? Nazpreet, are you there? Nilabri? Nilabri, are you there?
Yes, ma'am.
Is it clear? Or
Yes,
something needs
ma'am.
to be repeated?
No, ma'am.
Upinder?
Yes,
Upinder?
ma'am.
Is it clear?
Yes, ma'am.
Prabjot Singh?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, fine. So this is the cost associated with this. See, this is another method that how you will find the time complexity. For I is equal to 1 to n, cost associated with this C1 and this is n, fine. And for j is equal to 1 to n minus I, so we have to give the summation I is equal to 1, n minus I plus 1. Now if aj is greater than aj plus 1, this again loop will work from 1 to n minus I. कहाँ तक जाएगा ये n minus I तक जाएगा. ये n minus I plus 1 क्यों है? Can anybody tell me why this is n minus I plus 1? Anybody can reply. Narendra, do you know why it is n minus I plus 1? I have given you the rights to unmute yourself. Narendra, are you there?
Yes, ma'am.
Please
Yes,
tell
ma'am.
me why it is n minus I plus 1. Do you know the reason of it? Yes or no? Please reply. Narendra, please unmute yourself. I think you have again muted yourself. Yes. Do you know why it is n minus I plus 1? Yes or no?
No, ma'am.
Okay, fine. I tell you. ये जो लूप चलेगी 1 to n minus
Yes,
I
ma'am.
तक चलेगी 1 to 9 suppose it is going fine
Yes.
Now again, this loop will become false when its value is going to be 10. This loop will become false when its value will be incremented by 1, that is 10. Fine, हम loop चला रहे हैं 1 से लेके 9 तक, ठीक है. लेकिन हम next जब लेंगे increment 10, 10 is less than equal to 9, condition क्या होगी? False. So it will not enter the statements here. Fine. It will not enter inside the loop. That's why plus 1 is the comparison for which we are making the condition false. ये तो सबको पता है कि जब भी हम for loop चलाते हैं, आप for example you are to find you have to execute the loop for 5 times. 1, 2, 3, 4, 5. And again you will increment the loop by 1, that is 6, and 6 is less than equal to 5. Condition क्या होती है? False. So it is n minus I plus 1.
False.
Okay? It is n minus I plus 1.
Yes,
I
sir.
will explain it on the board if it is not clear. I will let you know how it happens. Is my board visible to you? Nanda, is board visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
For I is equal to 1, I less than equal to 5, I plus plus. We execute the loop in this manner, right? I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, and I is equal to 5. This condition will satisfy. 5 is less than equal to 5. Condition क्या होती है? 2. Then we will again increment the value of I by 1. That is 6. 6 is not less than equal to 5. That means this loop has worked for how many times? N plus 1 time. Sorry, n plus 1 time. But in case we are starting the loop from 0, so it is going to be 0 to n minus I plus 1. Fine? N minus I plus 1 time. What does summation stand for? Means we are actually, suppose I tell you, I say sum is equal to sum plus I. That means initially value of sum would be 1, then value of sum will be 3, then value of sum would be, क्या होएगी नरेंद्र? 3 plus 3 would be 6, 6 plus 4 would be 10, 10 plus 5 would be 15. For 6 it is going to be 4. That means
15.
we are summing the answers of each value of I, and I is ranging from 0 to n minus I. Fine. So it is, you can write n minus I plus. Okay. That's why it is being done. Okay. So it is this way.
Yes, ma'am.
Now this is very important. You have to associate cost of running, because we actually in time complexity we find the cost of running times, right? So C1 is multiplied with this constant Cn. C2 is I is equal to 1 to n minus I. Same statement I'm taking. N minus I plus 1. This I have told you. Then whatever is inside the loop, it will always execute one time less. क्योंकि 6 के लिए यहाँ पे condition check हो गई है, तो ये अंदर loop में नहीं जाएगा. It will not go into the loop inside. ठीक है, तो इसलिए ये हमेशा एक टाइम कम चलेगी. So I is equal to 1 n minus I. So it is n minus I. Then again C4 I is equal to 1 n minus I तक चलेगा and n minus I. So it comes out to be, how it comes out to be, I tell you. So this is best case, and this is integer flag is equal to 1. Integer I is equal to 1, 1 is less than equal to n, I plus plus. This you have done. This is the coding part. If flag is equal to 1 means you have encountered the element at the very first position. That means it is already sorted. Fine, it will break. So this is showing if aj is greater than done. See, j is equal to 1, 12 is again sorted. J is equal to 23, 34. See this. That means condition will never become true. This condition will never become true. So we will not need to swap any element. So it is equal to 1. Okay. This is this. Next is selection point. Actually, I made one slide. I think that it's being omitted, but I will tell you from here only because this part was here. we have n into C1 plus C2 plus C3 plus C4. C1 we have derived the constant. We have derived n from here. C1, C2, C3 because it was attached to the constant. Similarly, we have 1 into C2, so we have written here and this minus I, right? So it will come to be this. We can ignore this constant and this will be this way. C1 plus so these are constants. So this will be your n minus I comparison. And when we have n elements, we will begin to multiply by n. So this is n squared minus. So answer is theta. Right? So this is how it is being derived. I tell you, this is for the constant comparison because we are going to the loop inside loop. First is outer loop is for passes and inner loop is for comparison among the elements of the array. So this is there. Next is selection sort. See, selection sort is the technique in which we compare the element. First element we take it as sorted and we will find the minimum element from the rest of the array and we will swap the minimum value with the first location if it is smaller. See, this is unsorted array 5, 1, 12, 5, minus 5, 16, 2, 12, 14. So in step 2, this is not a part of your syllabus, but I'm just doing it because we were left with only this kind of sorting. So that's why I'm doing it. Right. So the first element we consider it as sorted. I is equal to 1, that is 5 is sorted. 2, 3, 4. Now for j is equal to 2 to n. Fine. We will compare ai with aj. Fine. If ai is smaller than aj, then there is no need to swap. Otherwise, temp is equal to aj, aj is equal to ai, and ai is equal to fine. So this is this way. So we start 1. 5 is less than 1. Okay. You will simply swap it. I'll tell you how. Unsorted elements are from 2 to 8. So minimum j is 1 and min-max is 5. So find the smallest value from the entire sorted array. So if I say 1 is less than 12, see how it will do this. 1 is less than 12, okay, condition is true. 12 is less than 5, no. So first of all, 1 will come, ऐसे आएगा, फिर ऐसे आएगा. Then 1 minus 5 and 12. This 5 will, minus 5 would swap this way. I'm talking for j side first. 1, then minus 5, then 12. Then 12 is less than 16, again 2, 12 and 14. So it will come here because minus 5 is less than 1. Now this element will be compared with 1 ai. So it will become your element here. So minus 5, then simply swap it 1, 12 and minus 5. It's not the so let's see how it is going. Now step 3, minus 5, 1, 12, 5 and 16. Now again minimum element is 1. So 1 is already in position. So unsorted element will be 12 to 14. Now min j is 2, min max is 1, fine. Find the minimum value from the minimum element. Again 2 is there, so 2 will come to which position now? 12. See. So this will be 2 with 12. Okay. Again find the minimum value, which is 5, so it will remain unsorted at its position. So this way. Again 12, 16 and 14. 12 is smaller value, so this. Always you have to take the minimum value from the remaining elements and swap it with the last index of I. So this is this way. Fine. So swapping is done this way. The sorted part, the selection sort divides the array into two parts, the sorted part at the left hand and the unsorted part at the right hand. So smallest part is the selected from unsorted array and swapped with the leftmost element. That is the element which becomes the part of sorted array. So this process continues until the array is sorted. So this is your algo. See, सबसे पहले आपने क्या करना है? Min j will be equal to I. Min j is first position, that is element at the first location. Then min x is equal to ai. For aj, a plus y, for j is equal to I plus 1. If aj is less than min x, then min j is equal to j, else min x is equal to aj. Now see how this algorithm is working. How this algorithm is working. See. In pass 1, value of I is 1 and min j is going to be 45. J is equal to 2 and we have to find this. Find j is 34. 34 is less than 56. Condition is true. Okay. Then 34 is again fine. Now min x is 34. Next 56. 56 is already sorted because 34 is less than 56, so there will be no change. Now you will move to 23. See, 23 is less than 12. Okay. So I mean the element which we have sorted is now 12. Now min x will become 12 because we are saying that 34 is sorry, I tell you how to do it. Just wait. I'll just show you here with the execution of it. Otherwise, you will not be able to clear it. For I is equal to n minus 1. This is for passes. Okay. So let's execute this pass one by one for element 45. Is board visible to you?
Yes, ma'am.
Okay. So this is this way. For min I is equal to min j, that is value of I is equal to I. So it is going to be first element, that is 45. Next, min x is a of I. Right? So a of I, we will take it as 54. We are running the loop from I plus 1 to n. Now see. N equals 1. Okay. So for j is equal to 1 plus I to or I plus 1 to n. If a of j is less than min of x. That means A of j will now start from equation number. This is equation number 1, 2, 3, 4, 5. J value is I plus 1, so it is going to be 2. So if A of j, that is A of 2 is less than 45, condition is 2. 34 is less than 45, condition is 2. Then again increment j by 1, j will become 3. A of 3 is less than 45. Fine. Then F3 is 56. 56 is less than 45. Condition can be. Fine. Then we'll again move it again. A4. A4 is less than 45. A4 is 23. 23 is less than 45. Condition can true. So my here what I have to do is I have not done any step here because there was 34. So condition was true. So my min max would be 34. Fine. Now 23 is less than 34. Now my min max would be 23. Fine. Now again A5, that is less than what? This A4, that is min max is 23 now. Yes. So my min max would be 20. Sorry, 12. Well, because 12 is less than 20. So now my min max would be 12, and I am going to swap this 12 by this 45. So this will become 12, 45, 34, 56, 23, and 40. See how this is doing. I again repeat. First of all, min j would be index of I, that is first location of I. Then min x would be A of I, that is 45. So first location in the array A would be 45, which is as min x, right? So for j is equal to I plus 1 to n, if j is less than min of x, fine. So j of n, you will start from location number 2, 34 is less than 45. Then you will make mu min x as this A of j. It is already written min of j is equal to j and min of x is equal to A of j. That means we will be changing the index. This I would be equal to now C2 and min x would be 34. Next, A2 is 34 is less than 45. Okay, condition is true, so it is already sorted. We are not going to do that. Then we will increment the j by 3 because we have to compare. Add your this thing because you have made this 34. Now you see A3 is this less than 34. Condition is going to be false. So next we will move to A4. A4 is 23. 23 is less than 34. Yes, condition is true. So value of I will be 4. Min j will be 4 and min of x will be 20. Now A of 5, that is 12. 12 is less than min of j, that is 23. Yes, it is true. So we are going to swap this value to 45. So it is 12, 34, 56 and 23. Is it clear? Or should I repeat it? Is it clear?
Clear, ma'am.
Repeat for everybody. Is it clear?
Yes, ma'am.
Yes, ma'am.
Again, I am going to repeat it for once. For I is equal to 1 to n minus I. Min j will be I will be the index position 1. Min x is equal to A of I, that is 45. First location, first element will be. Fine. Then for j is equal to 1 plus 1 to n, we have if aj is less than min of x. Aj of x is, sorry, A of j is 34. 34 is less than 45. Condition can true. So we will actually override the value of min j. Now min j would be this here. Min x would be 34 and value of I would be okay. Next, we will move to index number 3, 56. Now 56 is less than 34. Condition is false. So we will not enter inside. Then we will again increment the value of j by 1, that is 4. So j here is 4. So A of 4 is less than 34 because our new min x was 34. So value at 23 is less than 34. Condition is true. So that means we will be swapping the value of 34 with 23 and value of j will be 4. Now we will increment the value to 5. A of 5 is less than 23. Condition is true because 12 is less than 23. So min of x will be 12. Okay. Is it clear now? I hope it is clear. Kindly unmute you. I have given you the rights. Anybody having any problem?
No, ma'am.
Is it clear?
Yes.
Yes, ma'am.
Okay, fine. Only two people are speaking. Okay, now see. So this is this way. See, 12 is sorted. So 45, 34, 56, 23 and 12. So 12 will go to first position and 45 will come to second position. Now this is again 12, 34, 56. So now 23 and 34 will be done in the second pass. Okay, then 45 and 56. Finally, we will get the selection sorted algorithm. Now see this. For J, this we have already done. You can do it, I know. I'll tell you, for I is equal to 1 to n minus 1, that is, this is the outer pass. Pass 1, 2, 3, how many you require depends on the value of n. Min j, I have already told you, this is the value of index I. Min x is value of a of I. Means value at that particular location of I. Means यहाँ पे अगर 1 होगी value तो यहाँ पे a की value कितनी हो जाएगी? A of 1. Then for j is equal to I plus 1 to n, do aj is less than min x, then min j is equal to j. Min j means we will override the value of I with the new index of j. Then value at that particular index of j would be the minimum, and it is going to swap with the value of a of I. Fine. So time complexity would be, this is theta of n, and outer loop will also take theta of n times, so it is going to be theta of n square. So this is this way. See, C1 n, C2 is n minus 1, and C3 is 1 to n minus 1, I plus 1, C4 is I, and this, and C6, C7 statements are there. I tell you how to do this. Just wait. Okay, the cost of this particular statement is C1. Fine. Cost of this particular statement is C1. And how many times the loop is executing? N times. So we will write N in front of it. Fine. So min I and min x is equal to AI. This, anything which is inside the loop is going to execute for n minus 1 time. So it is going to n minus 1 time. So this is for j is equal to I plus 1 to n. Fine. So it is moving from j is equal to 1 to n times. Summation आएगा इसमें I is equal to 1 to n, and value of I will be summation क्या होगी? I plus 1. Fine. ये n plus 1 टाइम चलेगा ये भी. I plus 1 to n means n एक बार ही n तक चलेगा, उसके बाद जब हमने कंडीशन फॉल्स करनी है तो n plus 1 टाइम्स के लिए ये लूप चलेगा. Then this is for how many times? I plus 1, and this will be for 1 less than I, that is I times. This is again I times. This is the single statement, so it is going to take 1 unit time, and this is also a single statement, so it is going to take 1 unit time. So see this, C1 executes for n times, and anything inside is going to execute for n minus 1 time. Then C3 will be I is equal to 1 to n minus 1 and I plus 1 time. Anything inside this loop, that is I plus 1 loop. Wait. This is going to execute for I times. Again, this is going to execute for I times. So this is written here, I plus 1, then C4 for I times, and C5 for I times. Okay. This is your C4, this is your C5. And this will take 1 unit time, and this will take 1 unit time. Fine, I'll show you on the board so that everything would be clear to you. I just write the elbow on the board and find it. That this should not be anything. Minutes equal to. Let's suppose the cost level is C1, this is C2, and this is C. And this is going to use below the 1 time, and this is for n minus 1 time. Because anything inside the loop is going to execute for this time. Then for j is equal to 1 to I, I plus 1 to n, then b. What we have to do is min j is equal to j and min x is equal to j of j. Right? So this will be 0 and this will get the solution of I equal to 1 to n and then I plus 1. This is C5 work for n I have. So this is I. Yeah. Then min j. Next is your C6 and C7, that is min j. A of min j is equal to 0. Then A of n. This is going to be again 1 unit. So first I is equal to 1 to n minus 1. C1 it is going to execute for n times. This I have already told you. Then C2 is equal to n minus 1 because anything inside the loop will execute for n minus 1. Then for C4, I is equal to 1 to n minus 1. This one is I plus 1. So this summation of I plus 1. Then anything inside the loop will go less. So if I say 1 minus 1, it is going to be I times. So I is equal to n minus 1. You may write j is equal to I plus 1 or you may write I is equal to n minus 1 at 1 and the same thing. And again C6 because cost of this is C6 because inside the loop. So it is going to execute for I times. This is also going to execute. And this is just equating the value. We are just assigning the values to the variables. Or then it is going to take 1 unit of time. So this is this. So it is written C1 n C2 into n minus 1 equating all these costs. C3 is I is equal to 1 to n minus 1 I plus 1. C4 I equal to 1 n minus 1 I. C5 I equal to 1 n minus I. C6 n minus 1 and C7 also n minus 1 time because it is in the loop. So we can write this way. Sorry. Oh, it was in the loop, so it has to be executed n minus 1. Right? It was in, but it will take 1 unit time. So when you omit this C3 n square plus 1, n square plus n by 2, n square plus n by 2, n square plus n by 2. So wherever I am getting it, I am just getting it because the highest value of n is going to be 2. So the time complexity would be theta n square because we are taking the highest value of n. Okay. So I again repeat C1 into n plus C2 into n minus 1 plus C3 n into n plus 1 by 2 plus C4 n into n plus 1 by 2 plus C5 n into n plus 1 by 2. So it is going to give me highest power of n as n square. So we will consider the highest power of n as n square. That is Tn is equal to theta of n square. Nothing is to be taken. You can skip this part also. If you find it tough, you can skip this part. There is no problem. Now the recurrence equations. Is everything clear? Or you have any questions? Any questions if you have? Kindly unmute yourself and tell me.
No, ma'am.
No one is applying. Please apply.
No, ma'am.
Which thing is not clear?
Clear.
Everything is clear.
Everything is clear. No questions at all?
Yes.
No, ma'am.
No, ma'am.
Nancy, any questions?
No, ma'am.
Kabjot, Prince,
No,
Now
No,
reconciliations
ma'am.
are
Ma'am.
really need to be attentive. You need to be attentive while solving the reconciliation because we will be taking just 2 examples. And I'll show you what is the reconciliation. Actually, this is a topic which has been left in unit 1. So I'm just going to complete it. Okay. So reconciliations क्या होती हैं? Many algorithms like divide and conquer, we have done these algorithms, are recursive in nature. Recursive algorithms क्या होते हैं? Recursive calls कहते हैं when an algorithm needs to call, when a function needs to call itself, and that is called recursion. Okay. When we analyze them, we get a recurrence relation for the time complexity. We get running time as n, and we get the running time on input of smaller size. ऐसे क्या होता है कि जब हमने भी कोई फंक्शन बनाना है तो if our input size is large, only then we are able to calculate its time. But when input size is small, we can use the recurrence relations in order to calculate the time. So it is recursive function or description of function in terms of itself. That means calling of function itself is called a recursive function, and recurrence is a procedure in which the function calls itself again and again. So recurrence is recursively defines a solution when the next term is a function of a previous term. अब इसका क्या मीनिंग है? Suppose आपने what does last time mean? इसका मतलब ये है. See, you have to find factorial of 5. Then you will again, before calculating factorial of 5, you need to call factorial of 4. Then you need to factorial of 3. You need to call factorial of 2. Then factorial of 1 or factorial of 0. Fine. So this is your recursive nature. Recursive calls means you cannot calculate the factorial of 5 unless you call for factorial of 3, and you cannot calculate factorial of 4 unless you calculate the factorial of 3. This is called recursive call. Fine. So a recurrence relation recursively defines a sequence where the next term is a function of the previous term. Means जब आपने f of 5 बनाया तो f of 4 भी चाहिए, f of 3 भी चाहिए. That means f2, f3, f4 are the previous terms for the calculation of f1. ठीक है? So there are 3 methods by which we will be solving this recursion. First is a this substitution method, that substitution, then master theorem or master method बोलते हैं, and then there is a recurrence. So हम पहले करेंगे recurrence relation in terms of substitution method. So let's do it. How you will do it? I will explain it on the board because it will be tough for you to understand. We have to. You can do it side by side along with me. Suppose I have been given the relation Tn is equal to I've been given the relation Tn is equal to Tn of minus 1 plus n. Fine. So with the T naught, time of 0 is 0. This is the initial condition which we have been given. So we will substitute in the first step. This is the equation 1 which is given to us. We give it as equation 1. Put n is equal to n minus 1. So where a value of n is there, t of n minus 1 will be t of n minus 1 because n minus 1 value is equal. This will become my equation 2. So let's solve it. T of n minus 2 plus n minus 1. Okay. So this is my equation. Now put n is equal to n minus 2 in equation 1. So it is t of n minus 2, t of n minus 2 minus 1 plus n minus 2. Is it clear so far? Please tell me. Is the things clear so far?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Tn minus 1 की वैल्यू ये है, Tn minus 2 की वैल्यू ये है. कुछ भी नहीं किया. We have substituted इस n की जगह हमने डाल दिया n minus 1. ठीक है? So it is going to be n minus 1 minus 1. So it is going to be t of n minus 2. Instead of this n, I have put n minus 1, so it is here n minus 1. Now put n is equal to n minus 2 in same equation. हमें मिल गया t of n minus क्या आया minus 2 minus 1, so it is going to be t of n minus 3 plus n minus 2. Is it clear to every one of you? Please tell me.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. Now let's substitute. अब देखो फर्स्ट इक्वेशन में वैल्यू कौन सी होती है n minus 1 है ना, इसकी वैल्यू हमारे पास ये है, हमने इस वैल्यू को इसमें डालना. We have to substitute the value of Tn minus. The board is visible. Now let's substitute the value of t of n minus 1 in equation number. Let's substitute it. T of n will be equal to, what is the value of t of n minus? We simply copy this value, n minus 2 plus n minus 1 plus n. Okay, so this is the value. Yes or no? Fine. This will become equation number. Then from equation number 3 we have the value of Tn minus 2. Substitute the value of t of n minus 2 from equation 3 to 4. Okay, so this is going t of n. Instead of t of n minus 2, put this value. T of n minus 3 plus n minus 2 plus n minus 1, ये as it is आएगा, plus n. Now let's do it. n minus 3 fine. So this is the equation number 5. If I assume constants as k, then it will become n minus k, and this is n minus k plus 1. This is n minus.
Excuse me, ma'am.
Yes, beta.
After fifth equation, the board is not visible.
After fifth equation, the board is not
Visible.
Okay, fine. Now till it is visible till here.
Yes, ma'am.
Fifth equation is visible to you.
Yes, ma'am.
Okay, fine. So if I take k as constant, I can write 3 to as k. So I will write n minus k will be 3. Then again n of k कितना आएगा ये? K minus 1. Sorry, n of k minus 3 plus 1 will become minus 2. Then n minus k plus 2 up to so on n. Fine. Is it clear? Yes or no?
No, ma'am. It's again not visible after j bracket of n minus k.
Is the board visible now?
Yes, ma'am.
Is the board visible now? Hello? Is the board
Yes,
visible
ma'am.
now?
Yes, ma'am.
Okay, fine. Now I'll do it here. There is no problem. So if I assume constant as k, I will write t of n minus k plus n minus k plus 1 plus n minus k plus 2 up to so on. Supposing the value of n is k is 3, ये मैंने assume कर लिया. For 2, I can write minus k plus 1 because minus 3 plus 1 is equal to minus 2. So can I replace the minus k plus 1 here? Then minus k plus 2 will be minus 3 plus 2, that is 1. Fine. So this is this way. यहाँ पे देखिए दोबारा से समझा देते हैं. हमने कांस्टेंट 3 को k मान लिया है. For 3 it is k, for 2 it is going to minus k plus 1, and for 1 it is going to become minus k plus 2 up to so on. कहाँ तक जाएगा ये? n तक जाएगा. Okay, fine. Yes or no? Is it
Yes,
clear?
ma'am.
So if I assume n is equal to t, now assume n is equal to t. Assume n is equal to t. क्या बन जाएगा ये? बताइए. P of n will be k minus k, that is 0. Then k minus it will become t of 0 plus t of 1 plus t of 2 plus t of 3 up to k1. So it will become n into n plus 1 by 2. So it is going to become n square by 2 plus n by 2. That means complexity will be big O of n. देखिए बेटा, when I substitute n is equal to k, that means k minus k will be 0. I write k minus k plus 1, that will be t of 1. It is coming. K minus k plus 2 is coming here, t of 2. Similarly, t of 3 and up to so on n. That means it is giving you the sum of n terms. The formula for sum of n term is n into n plus 1 by 2, which is equal to n square by 2 plus n by 2. So it is going to become big O of n square. It is going to become big O of n square. समझ में आ गया ये? Is it clear? Or it is clear?
Yes, ma'am.
After fifth equation किसको समझ में नहीं आया? Please बताइए. Unmute yourself and tell me to repeat if you want me, or I will move further. Please let me know. Anyone? Or everything is clear? Everything is clear with all? Please respond.
Yes, ma'am.
Clear.
Yes, ma'am.
Yes,
Clear?
ma'am.
Yes, ma'am.
Assuming k n is equal to
Yes,
k,
ma'am.
so k minus k would be 0,
Yes,
k
ma'am.
minus k plus 1 would be t of 1, and k minus k plus 2 will be t of 2 up till n terms. Okay?
Yes, ma'am.
So it is giving me the complexity of big O of n square. Now please open your notebooks and try to calculate another example with me in the same method. Okay? Let's do it. T of n is equal to T of n minus 1 plus 1 is given to you. Fine. And you can unmute yourself, please, and you can talk to me in the similar manner. Now what I have to do is, अब क्या करना है मुझको? First step क्या होता है? Substitute n is equal to n minus 1 in equation 1. Okay, so what you will get? T of n minus 1 is equal to T of n minus 1 minus 1 plus 1. So it is going to give me T of n minus 2 plus 1, T of n minus 1. So this is my equation 2. Substitute T of n minus 2 in equation 1. What I will get? T of n minus 2 is equal to T of n minus 2 minus 1 plus 1, that is T of n minus 3 plus 1. Okay, so substitute the value of this to this equation. Substitute value of T of n minus 1 in equation 1. So क्या आएगा? Tn will be equal to T of n minus 2 plus 1 plus 1. Okay, so it is going to give me T of n minus 2 plus 2. Okay, I'm getting it as T of n minus 2, okay, plus 2. Now substitute the value of T of n minus 2, that is this value, in equation 1, what we will get? T of n, we will get T of n minus 3. You have to substitute here T of n minus 3 plus 1 plus 2. That means we are getting T of n minus 3 plus 3. Okay, is it clear?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, which implies, यहाँ से हमें क्या पता चलता है? If I assume constant to be k, the answer would be T of n minus k plus k. Yes or no?
Yes, ma'am.
Yes, ma'am.
And if I say board is visible till here,
Yes,
assume
ma'am.
Yes, ma'am.
n is equal to k. So n minus n plus n. So 0 plus n. Board is visible here?
Yes, ma'am.
No?
No, ma'am.
No, ma'am. No.
Okay, fine. Is it clear here now? So it is going to be n minus n. Clear, Ritika?
Yes, ma'am.
Okay. Value of k is again n. Substitute k is equal to n. So we will get 0 plus n. So time complexity will be big O of n.
Excuse me, ma'am.
Time complexity will be big O of n. Fine? Is it clear? Or not? I again write this here. If you are not able to the general form of equation number 5 is n minus k plus k. Yes or no? Assume n is equal to k. So if n, t of n minus n would be 0 plus n. That means it will be giving me t of n. So my time complexity will be big O of n. Okay? Yes or no? Please, Niladri, Upinder,
Yes, ma'am.
reply. Paras,
Yes, ma'am.
Parmeet,
ma'am.
Yes.
Yes,
is it
ma'am.
clear? Mridul, Mahajan, are you there?
Yes, ma'am.
Yes,
Is it
ma'am.
clear?
Yes, ma'am.
Fine.
Yes,
So this
ma'am.
is called backward substitution. Okay? This is called backward substitution. यही example मेरे पास है, मैं आपको दिखाती हूँ अभी. You may see. Replacing n by n minus 1 and n minus 2, we will get the following equations. Okay, this we have done. Substituting 3 in 2 and 2 in 1, we have now same thing, 3n minus 3n plus 2 plus n minus 1 plus 4. So this is this way. General form as n minus k plus 1, k plus 2 up to so on n. Now if we assume k is equal to n, we will get this way. Is this thing clear now? Yes, Parmeet. Parmeet, you can unmute yourself. Please ask the
Yes,
question if you have.
ma'am. Guleen wants to join, please.
You are not audible. Please be louder.
Hello,
Yes.
ma'am. Please, Guleen wants to join, please. Allow her.
Okay. Anything else? The topic
No,
is
ma'am.
clear.
Yes, ma'am.
Any
Everything
doubts
is
anybody
clear.
have? Prince, any doubts you have? Pawan?
No, ma'am. No,
Pawan, any doubts you have?
No,
Rajat? Rajat? Rahul?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, fine. Thank you so much. So, this is your backward substitution. Now, let's come to the master theorem. So, the master theorem is a cookbook method. It is basically a standard method for solving recurrences. You have the general equation Tn is equal to 8 Tn by 2 plus Fn. This master theorem we have done already when we have done the quicksort analysis. आपको याद होगा मैंने करवाई थी. The recurrence would have arisen in the analysis of any recursive algorithm when input size of size n is large enough. Then the problem is divided into a subproblems, and each of size n by b subproblems are solved recursively and results are recombined. And the work to split the problem into sub problems and recombine the result is called FN. You did merge sort, you did quick sort. There we divided the element according to the mid or pivot element, and we formed the two sub problems of A and B. Then we again divided the A sublist to N by B sizes. Okay, and finally in the end, when the elements were no more divisible, we started recombining them according to the given algorithm. If it was merge sort, then we sorted the elements and merged together. If it was quick sort, we have arranged the pivot element and then we perform the sorting on left hand side and right hand side respectively. So A is the number of subproblems, N is time required to solve the subproblem, and the function is time required to divide and recombine the problems. Okay, so this is the master theorem of it says. Now let's do the second part of it. ये मैं आपको बोर्ड पे कराती हूँ. These things will not be clear from here. You just note it down. I'll pass you the notes today only. So what does master theorem says? And we will do case for, we will do the example for each and everything. I already told you, Tn is equal to, board is visible or not? Is it visible what I am writing?
Visible,
Yes,
ma'am.
ma'am.
Visible, ma'am.
This is called notation sign. N of B and B is greater than equal to 0. Okay. So we have this we have written. इसके तीन cases होते हैं. Case 1, Cn will be equal to notation of n raised to power d if a is less than b raised to power. Okay. Case 2, Tn of is equal to notation of nd log n if a is equal to. Okay. Then case 3, we have Tn is equal to notation of n raised to power log b base a if a is greater than b raised to power d. Okay. So in the first case, we have example. Have you noted down these cases? We have three cases. Notation n raised to power d if a is less than bb. I tell you how to calculate the value of d. See, if fn something n square we have been given, then d value will be 2 because we are equating. I'll tell you how to do this in example. Tn is equal to notation of n log b base a, then if a is greater than b raised to power d. These are the three conditions. So we will assume the case for first condition, then second condition, then third condition. So let's assume the case for first condition first, then we will come to the second condition. So this is, the equation is 3Tn is equal to 3Tn by 2 plus n square. Now see, value, if I equate this equation 2 with 1, we get a is equal to 3, b is equal to 2, sorry, and d is equal to n square and fn is equal to n square. So d will be equal to 4. So this you see a is equal to 3 and equation says this condition is applicable if a is less than b raised to power d. So b is less than 2 raised to power 2, that is b is less than 4. So condition 1 is applicable. Okay, so this is applicable. Fn मेरा कितना है यहाँ पे देखो, this is my a t n by b and this is my fn. Fn is equal to n square So D would be equal to 2. So A is less than B raised to power D, which is equal to 3 is less than 2 raised to power 2. That is 3 is less than 4. Okay. So now what would be Tn? Tn would be equal to Nd, notation of Nd, that is Tn would be equal to notation of n square because value of D is 2. So it is notation of n square. So answer is notation of n square. Is it clear? I tell you again. The equation given to us is 3t n by 2 plus n square. Comparing master theorem equation with the case 1, a is equal to 3, b is equal to 2, we have fn is equal to n square. So value of d would be, I have written here fn is theta of nd and d is greater than 0. So comparing these two equations, we have n square, okay, f of n is equal to n square, which implies this way. F of n raised to power d is equal to n square, so d will be equal to 2. Now I check whether this condition is applicable. A is equal to 3, b raised to power d is 2 raised to power 2, 3 is less than 4. So it is implies d is equal to 2. That means this condition is applicable. Now what does this equation say? Tn is equal to notation of Nd if a is less than b raised to power d. So Tn is equal to notation of n square. So the complexity would be notation of or yeah, theta of n square for this case. Okay. Is this clear? Yes or no?
Yes, ma'am.
Is this clear?
Yes, ma'am.
Or you need to repeat it? Please tell me.
Ma'am, please repeat it.
Clear, ma'am.
Okay, I will repeat it.
Repeated,
Somebody
ma'am.
said that they want to repeat. So this is my case 1. The equation given to me is Tn is equal to 3t n by 2 is 3t n by 2 plus n square. This is this. Now if I compare this equation with Maxwell theorem, a t n by b plus fn. Okay, and fn you say fn says n raised to power d. So if I say a is equal to 3, b is equal to 2, fn is my n raised to power d is n square. Fine. Is it clear? So that implies value of d is 2. यहाँ तक क्लियर है? प्लीज बताइए.
Yes, ma'am.
Is it clear to you? A is equal to
Yes.
3, B is
Yes, ma'am.
equal to 2, and D is equal to 2 because n raised to power D is equal to n square area में given. Okay. Now you see whether this condition is satisfied. A value is 3 and B raised to power D is 3 is less than 2 raised to power 2, which implies 3 is less than 4 true. So that means it will be equal to theta of n raised to power d, that is n square. Okay, because d की value कितनी है 2. So the answer is theta of n square. Is it clear now? Is it clear now?
Yes.
Yes, ma'am.
जिसने बोला था रिपीट करने के लिए please tell me whether it is clear.
Yes, ma'am.
Now is it clear? I can again repeat. Equating A, you will get 3. Equating B, you will get 2. And equating Fn, you will get value of D as 2. Now you check this condition. 3 is less than D raised to power D, that is 3 is less than 4. So the condition is true and Tn is equal to theta of n square. Is it clear?
Yes, ma'am.
Guleen, why your connection is unstable? You are just going out
Yes,
and
ma'am. Yes, ma'am.
again and again. Okay. Now let's do the case 2. Let's do case 2. So for case 2, we have, first of all, let's write down the condition and then we will do. Second case says Tn will be equal to notation of Notation of ND log n with A is equal to B. That means in the equation there will be certain coefficients of A and B which are equal. So let's assume the statement Pn is equal to 2Tn by 2, okay, plus n. And comparing it with the equation 1, Atn by B plus f of n. Okay. A की वैल्यू कितनी आ गई 2, B की वैल्यू कितनी आ गई 2 एंड B की वैल्यू यहाँ से आएगी आपके पास Fn is equal to n raised to power d, so it is equal to n raised to power 1, so which implies B is equal to 1. Is it clear? Is it clear?
Yes, ma'am.
Is it clear? A की वैल्यू 2, B की वैल्यू 2, n की वैल्यू कितनी हमारी raised to power 1, so and B value will be 1. Now see, A is equal to B, case 2 implies condition is true, so case 2 will imply. Now what does this say? N raised to power d log n. So d की वैल्यू कितनी है 1 log n. So in this case the complexity will be time complexity will be big O of n log n. Is it clear?
Yes, ma'am.
Is it clear? I think nothing is tough. Equating A is equal to 2, B is equal to 2, Fn is equal to n raised to power d, and we have n की value 1 n raised to power 1. So it implies B value is 1. And statement says it will be theta of nd log n. So theta n raised to power 1 log n, so it gives me theta of n log n. Is it okay?
Yes,
Shall we move to next case?
Yes, ma'am.
yes, ma'am.
Is it clear to everyone? Please, all other students should also apply. Yash, Vishal, Subodh, please unmute yourself and tell me everything is clear or not. Subodh, are you there? Please unmute yourself. Yash, Mani, Ayush, Subedhi.
Yes, ma'am.
Clear or not?
Yes, ma'am.
Anish Podal.
Yes, ma'am.
Clear?
Yes, ma'am.
Subodh, Sujan.
Yes, ma'am.
Clear?
Clear, ma'am.
Sunny Sharma. Sunny, are you hearing me?
Yes, ma'am.
Is it clear? Please apply, Sunny. Is it clear?
Hello.
Yes. Is it clear? Please unmute yourself.
Yes, ma'am.
Is it clear? Okay, fine. Upinder Singh, UP, roll number lead 1800332.
Yes,
Upinder
ma'am.
Singh, is it clear?
Yes, ma'am.
Okay, fine. So let's continue with the third case now. Case 3 says Pn is equal to notation of n raised to power log a base b if a is greater than b raised to power. Fine. We have done two cases. A less than b raised to power d and a is equal to b. Now you are doing the third case where a is greater than b raised to power b. So let's consider an equation 4t n by 2 n plus n. Now you tell me, Vishal Plafia is there. Vishal Plafia, please unmute yourself. Vishal, are you there? Okay. Yuvraj Singh. Yuvraj. Vasu, please unmute yourself. Vasu Malik. Vasu Malik.
Yes, ma'am.
Value of A will be 4. Yes or no? If I compare this equation with A, T, N by B and Fn, what I will get? A value is, please बोलिए, also please बोलिए, A is equal to 4, B is equal to 2 and value of B will be, Fn is equal to N, which gives me N raised to power 1 and D will be equal to 1. Now you see condition is satisfying. 4 is greater than 2 raised to power 1. Condition is true. Okay? Is it okay, Vasu? Or you are not able to hear me? Anybody who can
Ma'am,
reply?
got it.
Okay? A is equal to 4, B is equal to 2 and D is equal to 1. Anish, you please unmute yourself. Anish Podal. Anish is there?
Yes, ma'am.
Okay. Is it okay? A is equal to 4, B is equal to 2 and D is equal to 1?
Yes, ma'am.
Okay. See, now what we will be doing, it implies Pn will be equal to notation of n log A base B. Log A की value कितनी है बेटा? What is the value of log A? 4 base 2. Yes or no? Can we write log 4 base 2 as this? Log 4 by log 2. Then can we write this 2 log 2 by log 2? Yes or no? ये समझ में आ रहा है कृतिका? Is it clear?
Yes, ma'am.
Can we write Pn is equal to theta of n log 4 base 2 because value of A is 4 and B is 2. Log 4 base 2 which implies log 4 by log 2. Log 4 can be written as log 2 square by log 2. Then 2 log 2 by log 2. Can we write it? Yes or no?
Yes.
Okay. Now, can we do this? We cancel log 2 by log 2. So what we will get this value? N square. What we will be getting this value as n square because it is n power log 4 base 2. So answer is n square. So Pn would be equal to theta of n square. I repeat it again. Pn A is equal to 4, B is equal to 2, Fn implies n raised to power d with value of d is 1. 4 is greater than 2 raised to power 1, that means case 3 will imply you can write log 4 base 2 as log 4 divided by log 2 and 4 is 2 square log 2 square by log 2 and this is the formula log n raised to power m होता है ना? Oh, sorry.
Yes, ma'am.
ये होता है log m raised to power m बनता है n log m ये होता है ना? ये वाला फॉर्मूला यहाँ पे लगाएंगे you will get 2 log 2 divided by log 2 log 2 cancel हो जाएगा and you will get 2 as a power of n. So it implies the answer is theta of n square. Is it okay? Yes or
Yes.
no?
Yes.
Is it clear to everyone?
Yes,
Or
ma'am.
any doubts?
Yes, ma'am.
Tanish Sharma,
Yes, ma'am. Yes.
Tanvi,
Yes, ma'am.
Samriddhi is there or not? She has come or not? Samriddhi? Samriddhi is there. Samriddhi, can you unmute yourself? Sarika? Nobody is replying. Rahul,
Yes, ma'am.
is it clear?
Yes, ma'am.
Okay. So, next, your master theorem is over. So, let's come to the reference tree that I will show you from the PPT itself. Then we will come to the very important topic. So, I told you all the 3 guesses. There is no problem. Now you can do. So recursion tree for this recurrence, you can say any recurrence you can say is like this. Suppose Right. Is the board visible?
Yes, ma'am.
Okay, fine. Whole board is visible or half of the board is visible? Okay, there are n elements which are to be sorted using merge sort. First of all, based on the mid element, we will divide the list into n by 2 elements. Okay, is it visible? Is it visible or not? Please tell me. Don't talk amongst you. Is it visible?
Yes, ma'am.
Yes, ma'am.
Completely
Ma'am.
visible?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Then you have, again upon the basis of mid element, you will divide this into two halves, n by 4, n by 4. Then again this will be n by 2, n by 8, n by 8, and so on. At every level, you are dividing the n elements into different sublists based on the, mid part. If I do binary search according to mid, supposing, sorry, if you do merge sort according to mid, you will divide the elements into two equal halves. Then again, we will find the mid and we will again divide this. Again, we will find the mid and divide this. Mid and find mid and divide, mid and divide. Finally, you will reach the atomic elements where no more divisibility of elements is possible. Is possible. That means we are recursively calling merge sort to divide until we reach the state where atomic elements are no more divisible. Means we cannot divide any elements, means we have single element at each step. Then we will start merging, that will also be done recursively. So it is a pictorial representation of whatever you are performing in any sort recursively. If any sort followed the recursion, this is a pictorial representation of that particular recurrence. See here n elements are divided into n by 2 and here n by 4. N by 4 means n by 2 raised to power 2. And again n by 2 raised to power cube, it will go and it will reach where n is equal to 1. But everywhere we are combining the n elements. So it is equal to log n. Fine. So it is equal to log n. Fine. Is it clear? Is it clear? Niladri?
Yes,
Is
ma'am.
it clear? Because आप merge sort करते हैं
Yes,
तो you
ma'am.
are basically dividing the list based on the mid. First 2 lists will be formed, then 4 lists will be formed, then 8 lists will be formed, and finally depending upon the number of elements you keep on dividing until you reach the individual elements. Then you sort them and combine them, and starting from there you start combining 1, 2 elements, then 4, then 8, then 16, then this way. Fine. So that is a recursion. Okay. Fine. So this is the pictorial representation of any recursion which you are performing on any problem. So that is called recurrence tree method. Okay. Now the thing which was left was quicksort analysis. So I tell you, rather worst case for the element that I will be talking. What is the worst case of it? Huh? First of all, we will talk about best case only, then the worst case will be understood. Suppose in quickshot, what we will do, we take pivot element, fine, it could be the last element, okay. Then we find the position of pivot element, it could be somewhere in the middle. Then we will start partitioning, or we will start finding the elements either towards the left hand side and towards the right hand side. You start sorting the elements, fine. So that means when the list is divided into equal halves, it will take how much of time? N log n. Log n for this side and log n for this side. So the elements are n log n time will be taken in order to perform the quick sort based on the pivot element. Okay. Now what could be the worst case? This I have already told you when we have done quick sorting. So what would be the worst case? Suppose the list is sorted. 1, 2, 3, 4, 5. When one element is sorted, it will give me one. How many elements are left? N minus 2. Two elements are sorted. How many are left? N minus 2. Three elements are sorted. How many are left? N minus 3. 4, N minus 4, 5, N minus 5. Now, if I see, it is giving me 1 plus 2 plus 3 plus 4 plus 5 up to so on n plus this n minus 1 plus n minus 2 plus n minus 3 and so on. Okay? And this comes out to be sum of n numbers, which is equal to n square by n and n by n. So that means it is big O of n square because we have to consider the largest power of n. If I am going to equate this, it will give me n plus n plus n. n कितने time होगा उतने time आ जाएगा. Suppose 10 terms है तो 10 n आ जाएगा. So it is no more of use to us. So we will consider this part only. 1 plus 2 plus 3 plus 4 plus 5 up to so on. N into n plus 1 by n. It gives me n square by n plus n by 2. Or you can write it this way. N square plus n by 2. So it becomes big O of n square. Is board visible?
Yes, ma'am.
Is the calculation visible to you? See, worst case में क्या होता है? If the elements are already sorted, so n minus 1 elements रह गए sort करने के लिए, then you have second element is sorted. That means 2 elements are sorted. You are left with n minus 2 elements. Here 3 elements are sorted. You are left with n minus 3 elements. Here 4 elements are sorted. You are left with n minus 4 elements. 5 n minus 5. So it is giving me sum of 1, 2, 3, 4, 5, 6 up to n terms, which is equal to n into n plus 1 by n, and it is equal to n square plus n by 2. So it is big O of n square. Okay. The answer is big O of n square. Fine. Now average case complexity says there is one case which is called randomized quick sort. Fine. I'm just doing it on the board. Okay. And I'll tell you why it is n log n. Next is randomized quick sort. Now, quick sort says we have to A, P, and R. A is array of elements. P is first element, index of first element, and R is last element. Okay, or pivot element, which is last element. But it is not always feasible to choose the last element as pivot element. Sometimes we choose mid or anywhere, any element from A to P to R. Suppose my list goes from 1 to 10. We may choose 6 as a pivot element. We may choose 7 as pivot element. Then accordingly, we will adjust that pivot element and make the partition of the list accordingly. That means on one side there will be say more comparison, and on the other side there will be less comparison. Suppose if 10 is there and 7 is my pivot element, the list is unsorted. That means if I'll find its position, I'll keep on trying from, first of all, I have to do the comparison from the left hand side, and after that we have to perform comparisons on the right hand side to find the correct position of, say, seventh element as pivot element. Okay, once it is found, my list will be divided into two halves. One will be the list which will be, it may contain 6 elements, and list on the other side may contain 4 elements. Fine. So that means total 10 elements are there. That means whenever I choose random element as a pivot element, it is called randomized quicksort, because the partitions will be made. It will not be, equal partitions. It will be like partition on the left hand side can be more, can have more elements than the partition on the right hand side. Fine. Means left hand side के अंदर एलिमेंट ज्यादा हो सकते हैं right hand side से, because हम जो है वो pivot element कोई भी random choose करें. We are choosing some 7, 8 as a random element, and towards the left hand side there can be suppose 5 elements, 6 elements, and towards on the right side we can have 4. That means these will be more and these will be small. So this is called randomized quicksort, and that is generally the average case complexity. We take a generally in case of average case complexity, we take randomized quicksort. So the algo for randomized quicksort is, सबसे पहले we have to find the pivot element from the list, right? So for and random number is generated by pseudo random generator. Pseudo random generator is a procedure which generates the random number from a given range. So for random A, B means we have to find the random number from A to B, and we will obtain new pivot using pseudo random generator. So pseudo random generator is a procedure which is used to generate the random number as pivot element between A to B. Then set QP is equal to Q of I, that is return the value of, return the index value of pivot. We have found the pivot, you will return the index value of pivot to QP. Okay, then return partition, value of partition, you will arrange the pivot element, and then you will set, give the limit for Q, P and R. You return the partition value, that is small q, as small q. Okay, then same algorithm is followed. If P is less than R, quicksort के लिए जो हम लगाते हैं, P is less than R, then first of all Q is equal to randomized quicksort, A, P and R. So this will give you the value of pivot element after adjusting into the array. Then we will again call randomized function from A to P comma Q. Then again randomized quicksort A to Q plus 1 comma R, and this will sort the element accordingly, and the average case complexity would be n log n, because we are combining the n elements, but before combining we are sorting and dividing the list into two equal halves, or two halves which may not be equal, which may in which left part may be greater than right hand side. So in which left hand part will be greater than right hand side, or right hand part may be greater than left hand side. So that that can have average case complexity, because the lists are not divided into equal halves, but the comparisons which would be done, that would be roughly equal to the best case. Fine, so it would be n log n. Okay. I think, okay. So it is again n log n. So average case running time is much closer to the best case because partitioning produces 9 column 1 proportional split. The recurrence will be this. This is no user for you. Now, what is polynomial time efficiency? See, we have seen the time, runtime of the problem size could be n square. Maximum time could be n, fine. So the algorithm with the polynomial runtime have the property that with the increasing problem size, the constant running factor or running time also increase by a constant factor. इसका मतलब क्या है कि अगर आपकी इनपुट जो है वो 100 से 1000 हो रही है, उसी तरह से आपका जो टाइम है वो भी बढ़ता जाएगा. दैट इज कॉल्ड पॉलिनोमियल टाइम. ओके, दैट इज कॉल्ड पॉलिनोमियल टाइम. ओके, सो लेट्स I think only we are left with 5 minutes. So let's do the polls. Students, is this clear? What is polynomial time? Anyone who can unmute and tell me. Part?
Yes, ma'am.
Is it clear? Whenever you solve any problem in polynomial time, that is n square n cube, that is called polynomial time. Fine. इसका मतलब क्या है कि जैसे जैसे आपकी प्रॉब्लम साइज बढ़ता जाएगा वैसे वैसे आपका टाइम भी बढ़ता जाएगा. सपोज प्रॉब्लम साइज हैज इंक्रीज फ्रॉम n to n स्क्वायर, तो इसी तरह आपका टाइम भी n स्क्वायर बढ़ता जाएगा. फाइन. सो दैट इज कॉल्ड polynomial time. Fine. So let me introduce the poll. Just wait. I'm just putting the polls. Only one question is there. Now you tell me, this is O(n) square. You tell me what is the complexity of selection sort that we have done. How many loops were there? Hurry up, vote for it. I'll just give you one. How many loops were there? What would be the time complexity for selection sort? Only 4 or 5 people have voted. Hurry up, 46 people are still there in queue. Hello. Uh, I hope all the topics are clear. And if you're not clear with anything, kindly WhatsApp me personally, or you can call me. Okay, I will make you the topic clear. Okay. And
Okay, ma'am.
Okay, ma'am.
we can have sometimes tests in coming future. I just want to give you a test because in DAA it is necessary to have some test. Can what at what time we can plan? You just tell me next week at what time we can plan. Have you implemented the problems or not? Have you implemented the algos or not so far? बच्चों ने कुछ implementation करी है आपने अभी तक?
Yes, ma'am.
ऋतिका एंड बस ऋतिका नहीं करी है, बाकी किसी ने नहीं करी? Please tell
Yes, ma'am.
Yes, ma'am.
who has
Yes,
implemented the
ma'am.
codes for the algorithms.
Yes, ma'am.
Ritik, you have done? Ritik, you have done the implementation? Rohit Kumar Singh, have you done the implementation? Please reply. Please reply. Please reply, Rohit Kumar Singh. If you are listening me, please reply. Have you done the implementation of the algorithm? You told now that you have attended all the classes. Narinder, have you done? Mridul, Pushpit,
Yes, ma'am.
Pushpit,
Yes,
have you
ma'am.
done? Pushpit Kaur, have you done?
Yes, ma'am.
Okay. Rahul, Rahul, have you implemented the codes?
Not all, and
नो प्रॉब्लम, तो ठीक है, कोड इंप्लीमेंट कर रहे हैं कि नहीं कर रहे हैं?
मैं वो मेरी विंडो को ना लाइसेंस में प्रॉब्लम आ गया था, तो उसको थोड़ा सा दिया वापस जहाँ से लिया था, तो इसलिए मेरा पीस मेरे पास नहीं है अभी, बाद में कर लूंगा मैं जब
स्मृति,
आएगा।
Yes,
स्मृति,
ma'am.
have you
Yes, ma'am.
implemented the codes?
Yes, ma'am.
Was today's lecture clear to you?
Yes, ma'am. It was clear.
Okay. Audibility, voices, okay?
Yes, ma'am.
Okay. Shamanjang,
Yes, ma'am.
Shamanjang, are you there?
Yes, ma'am.
Have you implemented the codes?
Yes, ma'am.
Please, when we can have the test in next week? आप मुझे बताइए, फ्राइडे को ले लें टेस्ट आपका?
Yes, ma'am.
Please raise your hand who want to have test on next Friday. Who don't want
Yes,
to
ma'am.
have next Friday? I am planning for your test because the confidence will be built only if you will be giving me the test. I'm seeing lots of hands are raising. Okay, I'll put self-evaluation test in the group, and you will provide me the answers because this won't be your MCQ part. This won't be kind of MCQ. Fine, it would be a subjective. ये सब lower करना शुरू हो गए हैं, तो subjective paper ही होगा, and I will post a PDF into your group, and we will sort it, solve it individually, and please don't copy the test. That is not for me, and you will just pass that test to me so that I should know how many of you have understand the concepts. Because if we will be having one class left with us before these sessionals, we can clear your doubts. I can repeat your topics from where things are not clear. Anything you want to get repeated? कुछ भी आप पिछला जो रिपीट करना चाहते हैं वो मुझे बता दें, because in next lecture I'll try to complete unit 2. Unit 2 का dynamic programming रह गया, बाकी we have done. So if you have any problems in any of the topic you want to repeat me, please let me know. ठीक है? WhatsApp पे बताना है, WhatsApp पे बता दीजिए, और if you want to tell me here now in the forum, you can tell any topic जो किसी को क्लियर नहीं है, किसी भी एक बच्चे को, I can repeat. Please tell me. Or you are clear with all the topics? Please let me know. Okay. So thank you for today, and we will meet again on next Monday, and we'll have your test on Friday, and probably I will be posting the videos of insertion sort today. Practical part, and others I'll do them by next Friday. Okay, so you may implement at your respective places if you have any doubts. Yes, Parth, please, you can unmute yourself and tell. Parth, you can please unmute yourself. I have allowed you. Please, you are raising your hand if you have any doubt. Please. पार्थ बताइए क्या प्रॉब्लम है खुशप्रीत का भी था खुशप्रीत डू यू हैव एनी प्रॉब्लम okay then we will wind up for the day and we will meet on next Monday and I'll be posting the videos regarding your practicals by next Friday the algorithms we have done so far that all the algorithms will be implemented in Python and I'll be posting those videos okay and you will implement at your own end and then let me know if you find any problems okay or you can share your screen shots with me so that I can revert back. Thank you for today and we will meet on next Monday. Thank you so much.